Hi, everyone. So thank you for staying. I know it's 6 o'clock on a Saturday. So I wanted to come here to talk to you all about open source and what I'm sort of calling this revolution of software testing. A little bit about background. I was here a couple years ago, 2016. The last time I was here, I took a little bit of time extra to sort of visit Columbus because I'd never been to Ohio before. Columbus has one of the best zoos in the world. I've been to many zoos. I went to the one in Tokyo, I went to the one in Berlin, zoos all over the place. Columbus, it's amazing. So if you haven't been there, you should go. If you haven't been lately, it's a really amazing zoo. They have manatees. But more pertinent to this talk, I've been working for about 15 years in and around open source communities. And when I started digging into that, it's actually been a bit longer than that because I didn't really know about open source when I first got online. So I did things like I put installation instructions for mPlayer on Debian on my website in 2002. This was back when it was really hard to get all the codexes installed to actually watch anything because there were codexes all over the places and it was really a big mess. So I ended up having people email me recommendations, additional codexes, and looking back, that was a very open sourcey thing that I did without even realizing it. So it wasn't until 2004 that I actually had my name in a README and or changelog for a software project. But I've been in the spirit of open sourciness since I got online, really, at the end of the 90s. I sort of got into Linux early 2000s. I joined a Linux users group out in Philadelphia and sort of got into Linux systems administration because I didn't really know what I wanted to do career-wise, and the guy who ran the lug had a small company, and he's like, why don't you come out and rack servers? I'm like, that sounds like fun. He's like, for money. I'm like, yes! More recently, I spent about 4 years working for HP, where I was kind of a donation to the OpenStack project. I helped run their CI/CD system, which is actually where a lot of the insight from this talk comes from, is my work there. I've also worked on a couple of books. I worked on the 8th and 9th edition of the official Ubuntu book. And then while I was working on OpenStack in 2016, I wrote Common OpenStack Deployments, which is using Puppet to deploy OpenStack. And in case you've seen me waddling around, I am 5.5 months pregnant too, so you get 2 keynote speakers for the price of 1. But he didn't help with the slides. Mostly he kicks me. He probably hates Linux. To get started, so I was reading a book recently. Who has read this or familiar with the Mythical Man Month? So this is a collection of essays by Frederick P. Brooks. He has been working in software for a long time. He's much older than me. So he has stories going back into the 1960s in software development and engineering. And one of the things I realized when I was reading this book was that in a lot of his essays, software testing is a topic that comes up incidentally. He doesn't really think about it, he just happens to mention the QA team or some sort of software testing that is done in the course of his discussion of software engineering principles. And being someone who's been working on open source, I'm a sysadmin by trade, but I love open source and I usually tend to gravitate towards open source projects where my sysadmin skills can be used. But I wasn't seeing a lot of software testing in open source. So, and I wasn't doing it professionally as my day job. So I was interested to read that software testing is so big inside of companies and traditional software development. And just to sort of step back to sort of say what we're going to define as software testing. This is the super vague description from Wikipedia. It's really just any sort of test that's done to give shareholders some sort of answer about the quality of software. Whether or not that's true, it definitely depends on the quality of the tests. But sort of broadly speaking, it's tests you do on your code to see, at least attempt to see if there's software quality. And there's also been this term that's been floating around a lot lately called continuous integration. Continuous integration is not software testing into itself. Continuous integration itself is just making sure you're committing code very frequently. So this can be every single day or multiple times a week. But the idea is you don't just go off and have a meeting with your little cabal of colleagues and write everything into a branch that only you have access to and then finally push 15,000 lines of code when you're ready to commit. And this is something that I first experienced when I started working on OpenStack 6 years ago. And it was because the OpenStack project is distributed across the whole world, across hundreds of companies. And so the only way to do software development in that sort of model is by slowly working on features and pushing your code often. The project also has a very strong culture of code review. And there have been studies, it shows about 300 lines is about the biggest commit you can do and have people still reasonably review it. And speaking from experience, even 300 lines, you better have a really good friend who's reviewing that code because that's huge, even that much. So I was working at HP, on the open source project, but they'd also have me consult internally about open source processes for software engineering. And one of the meetings I went into, they were like, how can I land a feature in 300 lines? And I'm like, aha, you can't. Part of this software engineering of continuous integration is breaking up your features into multiple changes, describing in time like what each one of these is going to do to impact the code. It may do nothing right now, but you're setting the base work for other code that's coming soon. So that's really what continuous integration is. It's making sure there's transparency in your team and putting in all that work to make sure everyone is following along as you do the software development. Now, testing does come into this. So in continuous integration, first you commit code to a repository. Then it typically is built in some way. So this is, if it's compiled code, it may be compiled. It may be built into a package. It may be just dumped into a tarball, maybe built into a container. And then in that form, it is then tested. So if it's built into a Debian package, it may be unpacked and then installed on a Debian box to make sure it works, and then some tests run in it to make sure everything goes well. And then you also have the CD part of this. There's like CI, CD, and continuous deployment or delivery, depending on whether you're shipping software to a web browser or an app or something, or if you're just shipping something that's going to go into a box and then shipped off to customers. This idea of continuous delivery or deployment is where you're releasing your software very often to close the feedback loop between you and your customers, to make sure that your customers are getting the latest features really quick, and when they run into bugs, your developers actually remember what they wrote. So testing does end up getting into the CI. So this is sort of like, in traditional software development, this is all coming together in these past few years. When I actually started working on the OpenStack team, I didn't know what CI meant. They hired me, and they were like, you're going to be on the CI team. And I'm like, I was excited because I was going to work on an open source project directly doing operations. I passed all the interviews, I know what I'm doing, but they're like, CI. And so like a month in, I'm like, so is our team continuous integration or core infrastructure? They're like, yes. I'm like, all right, that works. So this is 6 years ago, barely knew what CI was, and now like CI/CD is all over the place. So when you look at this from a testing framework, like standpoint, what I was seeing inside of HP and what I read in Frederick P. Brooks's book was that there's software that gets completed and then by the developers, and then it's sent off to the QA team. These teams were heavily siloed. They don't really like each other because all developers do is write broken stuff, and all the QA stuff that people do is yell at them. So these weren't really teams. They don't really know each other. They may be working in different offices, and all they get to communicate is like sending code and sending mean reports back saying everything's broken. So you end up with this opaque report that may come like days or weeks after you send the code to the QA team. By then you're trying to move on, but now you have to go back and fix everything because you have all these reports that are saying tests failed and you need to go back. So teams are very isolated. What I found when I started working in a continuous integration environment was that this was very much changed. So because there's small bits of code tested and every single commit has the code tested, you end up with a very, very small delta and very few things to change. So you don't get a report back after 2 weeks, you get a report back after 45 minutes, and then you can go ahead and fix your code right there, while it's still, the change is still really small. So you get this immediate feedback of whether you're passing tests, and developers end up working much more closely with the QA team. So I was on the infrastructure side, so all I was doing is making sure Jenkins was running, right? But I was able to see all of this because I see developers committing code. I see the QA team coming in and working with the developers as their tests are failing. So people would come into our IRC channel and say, my test failed, and I'm like, I don't know why it failed. I mean, over time, it turns out I got really good at Python debugging. I try to help them, but it would inevitably be someone from the QA team who, on the tricky problems, they would come in and interact with the developer and say, this is why your test failed. Here are the logs coming from our CI system. So it really changed the dynamic. Developers and QA actually started becoming much more tightly integrated and more friendly with each other. And the QA people would sometimes come in and review code, and they would comment on code coverage for testing. And they'd say, hey, you need tests on this change. And so they would work more closely together. So it seems like to me that continuous integration was a really good system. So OpenStack is a great example of a project that does testing. But when I look back at my sort of history in working in open source projects, how many people saw there were public tests running on your open source project in, say, 2005? Yeah, that is no one. So open source has done these really great things around software engineering that have made it better. So much so that some companies are doing these inner sourcing workshops where they're taking open source principles and teaching them to their software engineers inside of companies. So open source pioneered things like distributed collaboration because there are contributors from all over the world. They pioneered small commits because you have people reviewing the code. And I know from experience, if you submit a giant patch and you've never met the maintainer before, they're either never going to look at that patch or it's going to take them a really long time to get around to it until they have time. And then also descriptive commit messages, by which I mean when you do a commit, you don't just say what the commit is, what the change is, because you can see that by reading the code. You explain why you're making that change, which is something that, since a lot of open source projects are distributed, it's really important to tell people why you're making a change. So open source, lots of great things. Software testing, not one of them. So as we look back, there's software testing and QA, these things going back decades. Pretty much as long as there's been software, there's been testing for it. But open source projects, a lot of them didn't have testing at all. Or testing was done inside of a company that happened to be using the software. And how this typically manifested was that a maintainer of a software project would start getting random patches from this one company. They'd be like, where are these patches coming from? Who are these people? And it would turn out that the company had started running some internal tests of the code, and then every time they found a problem, they'd start submitting patches to the project. And this is the best case scenario, because most of the time, they wouldn't bother submitting patches to the project at all, and they just patch it internally and move on. That's not good for anyone. And I did speak to a few open source projects in preparation for this presentation. And another thing that I noticed when I was talking to them, these were a few projects. One of them was pretty big that didn't have software testing, a couple medium-sized, and a couple what I like to call egg timer projects, which are very small personal projects with one maintainer. And some of them have they have a bunch of bash scripts and stuff, so they test it locally. So they want to review a patch. They run a bunch of tests on their laptop that are not integrated at all with their open source project. And they say, yeah, this code looks good. It passed all my tests that I run on my laptop. And that's their CI system or their testing system is just a bunch of scripts that no one has access to and doesn't know the contents of. But all of these, from no testing to testing in companies, they're not integrated into the open source process. So when you submit code, you have no idea what the criteria is, really. There may be a README about how to contribute code or something to try to help them guide their way. But it's a really opaque process. And sadly, this is something we've gotten very used to. We just submit code and hope it goes well, and the maintainer accepts it. But it turns out we really need public software testing. One of the things that I saw recently, I was at KubeCon in Copenhagen. No, that's not where I was. No, I was at the Open Source Summit in Vancouver. I do a lot of conferences. And one of the things that Google committed to is Google is where Kubernetes came from. They released it as open source, and it's now part of the Cloud Native Foundation. But Google was still running all of their testing infrastructure. So they have committed, it's like $5 or $8 million over the next 3 years to help bring that software testing thing into the community. So we're talking real money from a huge company that understands the value of making sure software testing is public and controlled by the community. And that spoke volumes to me. I was like, this is really something, because we're not just going to rely upon the big company who's been funding a lot of things anymore. We want to bring software testing into the public realm here. And so there are a few reasons why we want this. So first, so I say like a clarity of process. So when you commit code to a project, you can see the actual tests that need to pass in order for your code to come into the project. And that means you're not, maybe the first time you contribute something and all the tests fail, that's how you figure out what the process is, but at least you have that sort of feedback. You may have the exact log files, the exact job that ran, but you're getting immediate feedback as to what you need to improve to make your patch ready for someone to actually review it. You can also do things like enforcement of coding standards. So Python has PEP 8, which a lot of projects adhere to. And in a big, huge project like OpenStack especially, where there's over 1,000 developers each cycle from hundreds of companies, having coding standards makes a big difference because everyone knows sort of what to expect styling-wise, and they're able to adjust their coding standards. They know what they're going to look at when they open up a new file. And this is something that computers are really good at and we're really bad at. So if you tell your CI system just to start doing linting or run PEP 8 or something on your code, they can find out where the problems are. Another thing that is hugely important is integration testing. Integration testing can take the form of how a certain patch interacts with other things that are close by it in the software, but also in projects that are more modular, how it impacts the environment that it's in. So again, like a project like OpenStack has lots of different pieces. So you're working on the compute piece, but a change to your compute piece may impact networking, it may impact storage, and since you're really focused on the compute stuff, you might not realize how your change is impacting other parts of the project. This is also good for testing different types of use cases, because you might not realize that your change actually impacts all these pieces all the way over here that you've never used, so you never bothered testing on your laptop. But it does make it easy for the system to run it automatically and catch things. And I'll talk about it in a couple of minutes, but there's also this initiative to do cross-project testing. So there's several big sort of cloud-native projects that have gotten together, and they actually test against each other's patches. So there's like the Open Daylight project, now sometimes runs tests against changes to OpenStack. So they know if they break on one of OpenStack changes or vice versa, you get some sort of feedback about that. And this is really exciting for me because I happen to love software testing, it turns out. And it's really interesting to see more projects working together across even project lines. And this is like going even way beyond like what you'd normally think of integration testing and beyond what most companies end up doing. Another thing that computers are really good at, looking for security vulnerabilities. So there are certain patterns in your source code that can lead to security vulnerabilities. Obviously, this is something computers can do really well up to a point, but that point is the really boring stuff. When you're reviewing code, you don't want to be looking for the boring stuff. You want to be using your human brain and finding all the interesting things that are wrong with the code, not looking for really simple problems. So you can do security vulnerability test detection of like different snippets of code, or looking for known vulnerabilities. Another thing that's somewhat related to this, there are some scanning things that can detect code that's been copied. And it does that by comparing it to known code bases that are in that similar space. So you can catch licensing changes, or licensing non-compliance issues and things. And this is really important inside of companies, and it is important inside of open source projects too, because some open source projects have had to pull code in the past because someone copied it from somewhere else and did not disclose the licensing. And usually it's really innocent, like they just don't understand software licensing. And they said, hey, I found it on the internet, they must be open source, I can just take it. And we know that that's not necessarily the case. But especially as open source grows, I've been seeing a lot of software developers that I've been working with don't necessarily know a lot about open source. So open source didn't have a lot of tooling, but now there is actually a lot out there. Just in the past 6 years, since I started playing around with software testing in the OpenStack project, we've seen a huge shift. So in the beginning, I'd say we're talking, more than 6 years ago, we had this tool called Hudson, which was forked into Jenkins, and that was kind of the only game in town for a while. The only thing you could use was Jenkins for open source testing because that was the software that existed. But slowly you had other ones being brought around. There's a Mozilla developed BuildBot. There's GitLab, which now has like a whole CI/CD portion in it. And then there's also things that are sort of more focused around deployment, but they sort of are similar in the pipeline. You have Spinnaker, which was released by Netflix. You also need somewhere to put all the logs and the container images and like other stuff that comes out of a build. And so there's tools like Artifactory, which holds all of your testing artifacts as an open source project. One of the things that came out of the OpenStack project, because sort of when I left the project a couple of years ago, we were running about 2,000 tests an hour. And this is for everything from like doing simple Python checks to launching an entire instance of OpenStack and running integration tests on them. So about 2,000 an hour, that's like 2,000 VMs or more than that because you can run the Python tests really quick. This is like a huge fleet of machines. And if you're doing 2,000 changes an hour, that's a lot of changes. So you want to make sure they're all tested against each other. And that's somewhat unusual. That's a very, very fast-paced open source project. So they developed Zool to make sure everything was properly tested against each other. And in the creation of Zool, they actually ended up getting rid of Jenkins entirely because they were talking directly to OpenStack cloud providers without the need of any sort of intermediary. So Zool CI, they released version 3 a little while back, so it's worth checking out if you're interested. But proprietary companies have stepped up to the plate too. If you've worked on a GitHub project lately, you may have noticed there are now integrations that some like things that say like, would you like to integrate this like with a testing platform? And a lot of these tools like Travis and CircleCI, TeamCity, they will all integrate into your GitHub repo. And there's even in like the GitHub marketplace, you can look around for software testing and integrate these things really closely with your project. A lot of them have like free versions for open source projects, but I will talk about these things a bit more. But there's a lot of them out there now. And if you look, oh, how well you can see that, it doesn't really matter a whole lot, but the pipelines for these continuous integration systems are going to be pretty similar. So over here you've got a Jenkins file, Jenkins, open source, and you have like stages. You check out your code repository, you do some sort of build, you maybe publish whatever comes out of that. CircleCI, it's a slightly different config file, but again, you have a checkout, you have a run, you have a storing of artifacts. So a lot of these pipelines look very similar. And all of these tools allow you to configure it through the GUI, but I hate doing that, and you probably do too, right? I'll show you the config file, that's much more fun. Plus, the config file can be stored in revision control, which is like the best because I was working on systems and an open source project, and we want to know the history of how a project has been changed. But pretty much, these configuration files are very similar across platforms, whether you're using an open source one or a proprietary one. And then you end up with something like a pipeline. So this is Jenkins in their stage view. So I said there's a checkout, build. In this case, I'm publishing a Docker image to a local repository on GitLab, and then running a test against that container image. Once the test passes, I deploy the website. So I have a demo that I've done before, where I actually do this on stage, and it almost always works. But yeah, this is kind of what it looks like to have your code go through the process. A lot of these tools also have test reporting built in. So as I said, you're a software developer, you want to know if the test's passed. Gerrit has this little section in it where you can pipe in results. In this case, this is building the Ansible tooling for OpenStack. So you can see, so the first time you commit something, you know all these fail, right? But then as you get better at it and sort of learn the policies of the project, you can see like they're building documentation. They're doing an Ansible linter, which is just checking like your coding styles. And then they're testing the Ansible modules against CentOS, OpenSUSE, and a couple versions of Ubuntu. And when you click on each one of these, it brings you to the log files. So Gerrit's the code review tool, and that's pretty much what you interact with the entire time. So all of your test results come into there, and then once all the tests pass, that's when the humans come in and actually review the code, because they're like, all right, it's good enough for a regular person to come by now. GitHub has very similar integration. You might have seen this if you're working on any open source project that has testing in it. This is really cool for me because I worked on Gerrit and OpenStack first, and I only started working with GitHub like directly 2 years ago in any serious way for my job. So yeah, GitHub has like an integration too, and if you click on the details, it'll send you to the Jenkins server that ran that job. In this case, it's a change to a website that we were hosting publicly, or had the source code was public. So we did a test build to make sure that the website's still built, and then it would validate the links on the website. It was just a simple test that was run. So test reporting integrated into this process has been, I mean, leaps and bounds based on like what I saw 7 years ago even. So this brings us to the question of how you would do this for your project. So I'm gonna ask you now, how many of you are working on projects that have testing in them? That is not enough. How many of you want to have testing but don't yet? All right, that's a pretty decent number. So as I said, like, I talked to a bunch of open source maintainers while putting together this talk. And uniformly, every single one of them I talked to said that they really wished they could do software testing. Because either it was locked up inside of a company that they happened to know was doing software testing, or it was their company and they just weren't making it public. Or they had that pile of scripts on their laptop that they run before merging any code that no one could see. And they're like, well, I'm not gonna open source this because it's terrible. But they all lacked like one or more of these things. It was either time, especially on the smaller projects. The maintainers were so focused on making sure that their code actually got written that they were like, I don't have time for software testing. Like, I just wrote this in my free time, and I don't have time to set up a whole testing infrastructure for my little like recipe manager. Some of them also lacked the expertise, and this is related to time, of course. They just didn't want to take the time to learn how to run sort of a system. Because again, like most people who are maintainers of open source projects are developers, not operations people. And so they're like, I don't know how to build a CI pipeline. Or they're missing other resources. This could be infrastructure, because you actually need somewhere to run your tests. And that's not free for the most part. You do have to go the steps to actually get a place to run your software tests. And this is sort of where the money comes into it too. Because if you're using a hosted platform, you probably have to pay for it. If you're running your tests on a bunch of virtual machines, you have to pay for those too. So the question is like, where would you begin? If you were a small project or a medium-sized project, or you're trying to convince your boss that we really need software testing in this open source project. So there's a couple of routes we can go here. The first is going the proprietary route, and this is not what I'm gonna recommend. But I will say, there are a lot of reasons people go the proprietary route, and it's totally valid, actually. One of the things that these services try really hard to do is the value that they bring to the ecosystem is by making it really easy for open source projects and other people to get started. So I have some friends who work at CircleCI. They have developer advocates who go to open source conferences and give talks, give tutorials, and they're working really hard to make it super easy for anyone to use CircleCI. And then they give it away for free to open source projects. So people get familiar with the tooling, and it makes it easier for them to use. And then eventually they want to sell it, to their employers or whatnot. So they make it really easy to get things going. And I will say, not just because Jason's in the audience, but GitLab actually does a really good job of this too, and GitLab's open source. So you guys all come to open source conferences too, and you give great demos, and like we'll make it easy as well. So it's not just the full realm of the proprietary systems, but that is where they focus a lot of time and energy. Make it easy as possible. They want to make it easy to configure. They want to make it easy to integrate with GitHub, and pretty much everything they can do to make it super easy for anyone to add testing to their project. It often includes like all the infrastructure side maintenance. So you don't even know where in the world your job is running because you don't have to. You are just configuring a job to run Python tests. And not knowing where it's running anywhere in the world can be probably a bad thing too. But the idea is that like the host is this proprietary companies handle all of that for you. You don't need to worry about upgrading the Linux distro that your Jenkins server runs on. This is all abstracted out from under you. And the initial costs of this is often low. As I said, a lot of these give things away, or at least a certain number of tests per month or whatnot, to open source projects. But there's a lot of considerations here. Like, we're all open source people, right? So we know the pitfalls of proprietary software. The first one is asking yourself whether the service that you're using has some sort of open standard, or are they locking you in? With some of these services, if you want to, say, run some Golang testing, you need to write your software testing into their framework. So if you ever leave that service, you have to rewrite all of your tests. That's not good. That really locks you into the infrastructure that they're using and means that it's going to be less likely that you'll ever leave. And I will say that like, even across open source and proprietary, all the config files for these things are going to be different. So there's not really an open standard for continuous integration testing, but more about like how you write your tests. Another thing to ask is whether the vendor has a history of communicating with their community. It's worth asking other companies and organizations and software projects in that space who are using them, like, do you have outages? Or as an open source project, do you find you have more downtime than you'd like? One of the things I actually really liked about GitLab is they've done public postmortems before, where they would say give out a report for their hosted service and say, this is what happened, we screwed up. And sometimes they really screwed up. But we knew about it, and they were honest about it, and they communicated that in a way that brought confidence to people who were using their service. So that's something you want to be looking for. Another one is how flexible their infrastructure is. If you can't run the test you want to run, or you're like somehow sacrificing the types of tests you're running just so you can shoehorn it into their testing infrastructure, that's not very good, because you end up either testing things that are not real tests, or you forego a lot of the flexibility that you could get if you were running the tests yourself somehow. And if they don't have the features you need, do they respond to feature requests and bug requests? Is there even a mechanism for talking to them at all? To say, I want to do this type of testing, but you only support that. And as an open source project, are you guys going to listen to me? Or are you focused on your paying customers? Something that may be less worrisome for an open source project, but also asking how they're using their data. Your data, really. So an open source project, you're probably putting all the logs out there for developers to review. But there have been instances of companies taking log files and taking open source project data and using that it's sort of the case that, if you're not paying, you are the product. So they're taking the product of all your jobs and aggregating it in a certain way. And you have to make sure that you are not running afoul of laws that are now put in place about data that is being generated based on your developers, but also that the vendor's not running into anything that's going to be causing problems. Again, less of a problem in open source because you probably made this all public anyway, but something to consider. Like, what are you doing with all those log files that I upload to you every day? And again, like, the initial costs may be zero or they may be really low, but do you have a plan in place for when they are no longer zero? Like, you had to put a credit card online to like run your tests. And now someone drives by and spams your project a ton, and now suddenly you have a $1,000 bill because someone is running tests automatically in your infrastructure. Like, do you have a plan to deal with that? Or if your project became really popular, and you are still just a single maintainer who's like, this was just a thing I do on weekends. And suddenly lots of people are committing to it. It's a great problem to have, but suddenly your CI system may not be able to keep up. So of course, I love open source. And I'd rather see projects go the open source route. And so you get all the stuff that comes with having open source. So like all the bad things about using the proprietary software. Using open source software gives you like full control over everything. If you want to run multi-node testing, you can. If you want to test on 17 different versions of Python, you can do that because you don't have to be beholden to what the CI system is going to be offering you. And one of the things that I think is often ignored as like an operations person looking into software engineering is that some people say they don't have the time or interest, but there are so many jobs in continuous integration right now, like way a lot. So building up your expertise in the field of software testing and continuous integration can be a huge boon to your career, whether you're a developer or someone working in systems administration. And so what I suggest to open source projects who are looking to go down this route is the first thing they do, maybe they don't want to do the work themselves. They're saying, I'm a software developer, I have no interest in running this whole testing infrastructure thing. So you should reach out to your community and see if there are any systems administrators in their community who can help. Who here is a sysadmin in an open source community who could help or be interested in helping? Who has the expertise to like help? Yeah, there are some people out there. That's really how I engage with open source. Like, I'm a systems person. I run servers for a bunch of open source projects I'm involved with. And they are so happy to have me because I'm helping them out. And I feel good because I can give something back to an open source project. So being present in those projects and then reaching out to your community to ask if anyone can help. And then whether you're a software maintainer or a systems person, familiarize yourself with the ecosystem that's out there, both the proprietary tools and the open source tools. Depending on your project, one testing infrastructure may work much better for you. If you're just going to do sort of unit testing on your code, very simple things, you may want a very simple CI system. If you're working on something that's a bigger infrastructure project, you may need more advanced tests, and you may need a lot more flexibility. There's also a couple initiatives out there right now. So there's opensourceinfra.org, which is a website that I host, and the source code's all on GitLab. But it's where open source projects can come and add their infrastructure to our list of open infrastructure projects. So we have projects from, of course, OpenStack and the Apache Software Foundation, Mozilla, and other organizations in there who run open infrastructures, at least in some way. And this is not necessarily CI/CD based. This could just be they open sourced all their Puppet configs, and you can go to their website or their wiki and see them. And so you can see what other open source projects are doing with their open source tooling because they've made them public. There's also the initiative called OpenCI.io, and that's the one I referenced earlier, where Open Daylight and OpenStack and several other of these large, mostly networking related projects are actually starting to test their changes against each other's projects. They have a mailing list, they do monthly meetings. We've done a few get-togethers in person. We did one, it was at the OpenStack Summit in Vancouver a few months ago, where we had a whole talk, a whole 2 days or so, where we all got together and talked about integrating continuous integration and things across open source projects. But that's a great resource to see what other people are doing in this space, especially big projects who like have employees and are being really serious about it. If you're worried about money, there are free resources out there. So first is that you can approach the cloud providers. A lot of them have trial accounts. A lot of them also will give certain allocations to nonprofits and things. So one of the things that I've seen open source projects do is they'll affiliate themselves with with a nonprofit in an official capacity. So the software is now in that nonprofit, and this could be a nonprofit that's in their industry, or some sort of it could be even a 501c6 professional organization that has an umbrella for software projects. and then you could like sort of sneak in into their resources. But like partnering with people who do have the resources is something that a lot of projects can do. But on the free level, like there's a lot you can do already. So that is kind of where I come to a conclusion here. So welcome to the software revolution of testing, and I hope you all can be part of it. So. So we have time for questions.
I will be the mic runner. Who would like to ask a question? Raise your hand. Please wait for the mic.
Since you've been doing like open source development for a while now, I was curious on your thoughts on how to start a project with the idea of using continuous integration, continuous development in mind. So for instance, would you commit the test to the repository first, or only commit code once you have a working test? And also, like, what would your initial configuration be to make everything easier to automate further down the line?
Yeah, that's a really good question. So one of the things that I've seen some software projects do, and this is both in open source and in proprietary software, is that part of the review process and part of writing code is writing tests. So when your code is reviewed by your fellow developers, one of the questions on their list should be, did you write tests for this? And if they don't write tests, then you have to go back and rewrite write the tests. And I'm a very strong believer in that, because it never works when you write tests later, because you're like, I'll do that later, and we know how that works. So integrating that as part of your process, I think, is really important. And then if I was going to start an open source project today, I would definitely bootstrap like the whole testing infrastructure right then. Like I'd launch the project with CI from like the first commit. And just, one of the things that was really successful inside of OpenStack is we have a very strong community and culture of doing software testing. So like the whole OpenStack system of reviewing is based around a review system. All of the test results come into that review system. And really like there's no one necessarily who's a project maintainer. The people who have influence inside of the OpenStack project are people who do a lot of code review, and then they get the privileges to merge the code. So turning that into sort of this like thing that you can work up to, and the way you work up to it is by reviewing code and being a good reviewer who's trusted in the community. And part of that is by making sure that commits have software testing and that you have good code coverage testing-wise. So hopefully that answers the question. Don't be shy.
On the continuous improvement on the software testing, do you find that there is a speed reduction from doing individual private versus open source?
Maybe clarify that a little.
Like for example, let's say you work on let's say you work on a piece of software and the full time from the actual coding to development is 12 months if you did it in a private setting, versus open source where you do coding development would be maybe 6 months.
Yeah, so I don't have like actual statistics on this, but the place to look for that is like the DevOps world, because in DevOps, continuous integration and like CI/CD is like one of their main tenets. Like that is a huge part of what you'll see in like open source events. So I think some of the reports that have come out of like the DevOps world will include statistics about how much faster teams can deliver on products when they're doing things like doing small commits and making small goals and then like releasing continuously and doing testing along the way. But I know there are graphs and things and data that show that it is better. Everyone just wants cupcakes. All right, I'll be around for a bit longer. Come by, say hello.